It does make us wonder if perhaps we are seeking for signs from extraterrestrial life, or intelligent beings in the wrong areas, and whether we should instead be watching the wide spaces between the stars, instead of the stars themselves. The Fermi Paradox is the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of evidence for it. It bears the name of physicist Enrico Fermi, who is renowned for memorably asking, "Where is everybody?" when discussing the likelihood of extraterrestrial life in the universe. Welcome back to my channel. The paradox arises from the fact that given the vast number of stars in our galaxy, 10 to the power of 11 stars, the number of galaxies in the observable universe 10 to the power of 11 galaxies, and the age of the universe, it seems very probable that there are other intelligent civilizations out there. Despite decades of searching, we have yet to detect any clear signs of their existence. There are numerous potential explanations for the Fermi paradox, ranging from the possibility that intelligent life is extremely rare, or short-lived, to the idea that advanced civilizations inevitably self-destruct, or choose not to communicate with others. It is possible that we simply haven't searched long enough, or in the right ways or places, or maybe we are not able to recognize the signs of extraterrestrial intelligence. The Fermi paradox remains an active area of research and debate among scientists, and is often cited as one of the most intriguing and perplexing questions in the field of astrobiology. We did find nothing searching the galaxies, but what if an advanced civilization not resides inside a galaxy? What if a K3 civilization is populating the intergalactic voids? Because for a K3 civilization, preserving original biology, of flesh and blood, is in my opinion, not likely to happen. They should already went digital long before reaching K3 status. The universe is simply too big for a biological being to conquer galaxies, it's just counterproductive. For interstellar travel can be feasible, from generation ships to life extension technology, it can be done, although interstellar distances are very, very big as well. However, the technology for interstellar travel that make possible, on paper at least, that sort of technology, capable for relativistic speeds, reaching the stars within a human lifetime, subjectively speaking and all under known science. In any situation, for a fast-moving ships doing 10% or 20% of the speed of light, combining with life extension techniques for intergalactic travels? I will not put my money on that. For a biological being at least, you need to go digital, and in the same time, alter the subjective passage of time as well. A void is the right place to colonize. A digital empire runs better in cold environments. A void in this case, is the best candidate to open shop. Do we have such voids in the universe? The answer is yes, but what is amazing, is the so-called Boötes void with a length of more than 300 million light-years. It is enormous by any standard, and raise the question, could this void be artificial in nature? If it could have developed naturally, under the cosmological model, there is much uncertainty. This consequently caused many people to ask, whether it might actually be of artificial origin. This could be a solution to the Fermi paradox, the apparent inconsistency between how big an ancient universe is, and how empty of extraterrestrial life appears to be. The presumption that colonizing space is feasible, something most species would accomplish, and that every star system, even the one they developed in, can support colonies starting with their own, should eventually be filled with a variety of homes, solar power collectors, colonies, and machinery. What we refer to as the Dyson swarm, or a megastructure, or at least, a collection of smaller constructs, purposely created so as to consume all the sunlight provided by that star. Why we don't see any signals when we stare at far-off stars, is not a valid question, or is not the right question to ask. The problem is, why we don't see them at all. As much time as it takes to populate a galaxy, even at rather anemic rates of population expansion, it is a very small amount of time in comparison to the age of a galaxy. The humanity is not the first arrived on the galaxy's stage. If ET exists, they would have time by now to colonize the galaxy. Why by now there is no evidence of a galaxy spawning empire, rendering every star in the galaxy invisible for the naked eye. And as more and more solar systems are colonized, and their suns gradually turn darker, as more of their power is used by the colossal civilizations surrounding them, we can expect to see dark bubbles forming inside galaxies that are slowly expanding outward. This would eventually consume it all, what is known as the K3 civilization spawning an entire galaxy. There is also no need for them to confine themselves to a single galaxy. If you have the technology to acquire a galaxy, the logic hypothesis is that such civilization will want to advance and needs energy and matter to accomplish so. Since they commonly visualize a large expanding bubble of darkness, and see gaps that are genuinely such enormous, expanding bubbles of darkness, it is not unexpected that some individuals wonder if the solution is really that simple. It's possible that those gaps aren't really empty spaces at all, but rather the regions of our universe that are most densely populated. The universe is big, mind-blowing big. There are on average 10 to the power of 11 stars in a galaxy, and there are 10 to the power of 11 galaxies in the observable universe. If you point a telescope in any random direction, you'll probably be staring straight ahead, to the edge of the universe, rather than directly at a star. Because there is so much empty space, you typically reach the observable universe's edge before it passes through a star. So it makes reasonable that scientists focus the hunt for life in between the stars because of how enormous space is. But let's get back to the space between the galaxies. As predicted by the Dyson dilemma, these spaces are natural. The intergalactic space is fairly sparse in general, but include many stars, is just not fully empty as one may think. The mass density of the voids is typically 10% of what we consider to be the average mass for the universe, and they do hold a sizable number of galaxies. Given that we observe this enormous empty space in the cosmos, it would seem implausible to think that life, going into such places, would arbitrarily choose to avoid them. We would have to assume that such voids are home, and are the consequence of different civilizations' behavior, with various reasons for avoiding galaxies. They actually absorb them, swallow them, and turn every star in them into a Dyson sphere. There is no evidence that the Dyson swarms contain a considerable quantity of hidden matter, even though we should see their gravitational influence on nearby galaxies, outside of the gaps. Another part of that is that stars are not really hidden by Dyson swarms. We cannot see them with the naked eye, under visible light, but they glow in the infrared spectrum. Because all they do is change the frequency of the light they emit, from visible to infrared, energy eventually escapes as waste heat. In fact, they will be an easy hunt by the James Webb Space Telescope. In addition, if it didn't leak heat, everyone within would rapidly burn up, as the waste heat was transformed into infrared light, and heated to a temperature of roughly ambient. You do have a strong motivation to try to conserve energy, and keep a very chilly environment in a post-biological society, since doing so makes it possible to do computation, the lifeblood of such digital empires, far more effectively. It is, of course, always feasible for a civilization to discover a way to ignore the rules of thermodynamics. The scientists did look at the Boötes void, and even as a massive empty chunk of the universe, the hypothesis of being artificial, and the galaxies in it all transformed by a K3 civilization into Dyson megastructures, we don't see then in infrared, neither their gravitational influence over the neighbors. It's just not there, so the conclusion is that, however improbable, it is a natural phenomenon. This is another stunning fact that the universe is weirder than we think. They were merely caused by the universe's initial uneven distribution. Additionally, because the cosmos was considerably younger, if you see anything 10 billion light-years away, the universe was a lot younger, therefore unlikely to be the work of a massive supercivilization. Another issue is that the voids are expanding at the same rate as the universe as a whole. How cool it would have been if the Boötes void, or any other voids in the universe, would have been the home of vast intergalactic empires. The most straightforward method to utilize the resources most efficiently, in a post-biological society, would presumably be to convey information and data sparingly rather than in large quantities. You transfer information, not mass. You transfer bits, not matter. The efficiency of both your processing and electricity generation operations improves if you manage a digital empire, as cold as you can get. An intergalactic void is the best place your digital empire can ever want. It would then be exceedingly challenging to find such civilization, since all of those interstellar spaces would seem to be very appealing locations to reside. Those intergalactic voids would be much better, and those super voids would be even better. They might not worry about lag time to their neighbors even if they don't have FTL communication, if it means getting them much more efficient processing, which in this case simply means a larger population. You just adjust your subjective time. A 100,000 light years can be a second in this case. Real-time communications over astronomical distances become feasible. However, it does make us wonder if perhaps we are seeking for signs from extraterrestrial life, or intelligent beings in the wrong areas, and whether we should instead be watching the wide spaces between the stars instead of the stars themselves. This is it for today. Please consider subscribing. Thank you for watching.